Hey, what's up everybody? Welcome to this Masterclass video for Genelec. So some of you might know me, some not, but let me introduce myself. My name is Ummet Ozcan. I'm a DJ, producer, sound designer, software developer. I'm signed to Spinning Records. I have my own sub-label called Oz Records. So today, in this video, what are we going to do? We are going to talk about sound designing and why sound designing is so important for a producer. We are going to talk about different kinds of synthesis techniques and what kinds of sounds you can create with it and how it works. I will also show you how I created my own VST plugin called Genesis Pro. I've been working on that for the last 8 and 9 years, and I've released it last year in February. I'm going to show you which program I use for that and how it works. I will also do some sound design sessions. I will show you how to create certain sounds. So I hope you guys learn something from this video. Most of all, I hope you guys enjoy this video. So let's get started. So first of all, let's talk about why I think sound designing is so important for a producer. Now, before I got into synthesis, sound design, and developing my own software, I didn't know much about it. I knew how to make music, but I was always using the factory presets that was provided with any plugin or sounds that were created by other sound designers. Now, a downside of this is, of course, other producers use the same presets as well. And I mean, you can tweak it a little bit and change it a little bit, but it's still the same preset. And a good example of this is in the EDM songs nowadays. You can hear a lot of similarities in the leads, in the basses, in the plug sounds. This is because a lot of those producers are using the same presets. Only a few producers are capable to create their own signature sound. And that's because they know how to create their own sounds. Now, when I got into sound designing and software developing, I stopped making music for a couple of years and I just fully focused on learning everything about synthesis and sound designing and programming my own VST plugin. After a couple of years, I managed to create my first plugin called the Genesis that was released with Computer Music Magazine as a free plugin. So after that, I got into making music again, and then I noticed that it was a lot easier for me to create my own sounds. I mean, when I had a sound in my mind, I just played around with some knobs and I had the sound I wanted. And it was really easy for me to recreate sounds that I hear in other songs. So at that point, I realized that sound designing is essential for a producer. Because as a producer, as an artist, you need your own signature sound. And when you have your own signature sound, you will stand out more as an artist. This is exactly why I think it's very essential for a producer to know sound designing. So the next thing we're going to talk about are the different types of synthesis forms. Now, you have many synthesis forms, but we're going to talk about the most common one, and that's going to be subtractive, additive, FM synthesis, of course, sample-based synthesis, wavetable, physical modeling, and the granular synthesis. So let's get over to my computer so I can show you some examples of different types of synthesis forms and explain to you how it works. Okay, so welcome to my computer. As you can see, I'm using ImageLine's FL Studio. I started using FL Studio way back when it was 3.0 or something. That's like maybe 20 years ago. Back then it was called Fruity Loops. And it was called Fruity Loops because you could make loops with it. And I really loved it because it was like the old school way of creating loops, like the hardware drum computers. And since then, I kept using FL Studio. I didn't change it. I tried Cubase, Reason, but I really felt like FL Studio is my thing. I really loved the workflow. It was quick and easy. Now, it doesn't really matter what kind of program you use, of course. They're all basically the same. They have the same functions, the same features. You just have to find the program that fits the best for you, because at the end, it really depends on the person that sits behind the desk. Okay, so let's talk about the different types of synthesis forms. Let's start with the most basic one, called subtractive synthesis. Subtractive synthesis is perhaps the most common form. And you start with harmonically rich sounds and then subtract harmonics from it with a filter. So usually you have 1, 2, or 3 oscillators, and you can choose between basic waveforms like a sine, saw, ramp, triangle, pulse, or a noise. And then you can mix those waveforms. You can play with the octaves and the pitch. You can turn on the filters. You can use some envelopes on your filter or on your volume, and of course you have some LFOs, depends on what kind of synth you have, and you use some effects, but that's it. And you can think of it like sculpting, like sculptor starts with a large block of material and cut away until it becomes something else. Now, subtractive synthesis is kind of the same way. You start with a raw tone with a lot of harmonics and shape it and form it until it resembles another sound. Now, a good example of a subtractive synth is the Mini Moog or the Roland Jupiter or the Arturia Mini Brute. Those are great examples of subtractive synthesizers, but of course there are many, many more. Now, the second type of synthesis will be additive. And to show you an example of that one will be the Morphine from FL Studio. Now, what is additive? Additive synthesis is considered as one of the oldest forms of sound synthesis. It's dating back to its application in the pipe organs. By controlling and routing the air through various pipes, it was possible to create a variety of timbres. So where subtractive synthesis involves starting with a very harmonically rich sound, additive synthesis is the opposite. Usually in additive synthesis you start out by combining multiple sine waves of different levels and frequencies, and as more sine waves are combined, they begin to generate additional harmonics. Now, an example we got here. Now you can add more harmonics to create more complex sounds. It depends on what kind of plugin you have, but as you can see, Morphine has more generators, so you can combine different generators. Now, the next form of synthesis will be FM synthesis, and this one is a little bit different. Let me grab the genesis. So FM, which stands for frequency modulation, is a form of synthesis whereby one waveform modulates the other one. And instead of starting with a harmonically rich waveform, as in subtractive synthesis, usually FM starts with a pure sine wave called a carrier and modulates with another sine wave called the modulation. Now, this modulation creates harmonics in the audible carrier wave, combinations of multiple carriers and modulators, so-called algorithms, create more complex sounds. And a good example of the FM synthesis is the Yamaha DX7. So let me try to show you an example. We have two sine waves here. Now this will be wave A and wave 1 and wave 2. So wave 1 is going to be the modulator and wave 2 is going to be the carrier. As I turn on the FM, you will hear the very recognizable FM sound. Let me turn on the filter. You will immediately hear changes in the second one. Also, this is the same technique to create the very famous deep house basses. Let me see if I can quickly make one. So FM synthesis is very much used synthesis technique back in the 70s and the 80s, and it's still being used a lot, and it's also one of my favorite types of synthesis because you can create a lot of different sounds with it, from bells to basses to very glassy pads and sounds. So the next form of synthesis will be sample-based synthesis, of course. Now, sample-based synthesis involves recording of samples, a sound into a digital memory. And in the late 70s, early 80s, this was often a very expansive form of synthesis. Some of the first examples were the Fairlight CMI, which was a huge machine and was enormously expansive at that time. But of course, recently we have the very popular software versions, so-called Romplers, and good examples are, of course, Native Instruments, Contact, and RFX Nexus. So for those who are looking for ready-made sounds that can be tweaked a little bit, Romplers usually put huge sound libraries at your disposal without the need for doing any sampling yourself. Usually the Romplers, you have one or two oscillators where you can combine different samples. Now, sample-based synths can be useful when you're looking for natural sounds like pianos or violins or flutes, and it really depends on what kind of plugin you have. For example, in my VST, the Genesis Pro has also the option to use the sample-based oscillator, but as you can see, I added a lot of extra features so you still can do your sound designing and change the sounds to your own taste. So the next synthesis form is a very popular one, especially the last couple of years. And a very good example of that will be the serum. Now, of course, we're talking about the wavetable synthesis. Wavetable synthesis is a method of synthesizing sound using sample-based waveforms as oscillators. But instead of traditional oscillators, wavetable synths load each individual slice of a digital sample into a cell, or a so-called table. And then the synth scrolls or morphs the slices in the table, and the output is the sample as a sound. So the interpolation between those wave shapes is what creates the characteristic sound of a wavetable. And you immediately hear the very recognizable dubstep growl. So it's often used in music styles as dubstep. So that is a wavetable synthesis. So the next one I want to talk about is called the granular synthesis. And let me see if I can find, yes, here it is. I'm going to use the Fruity Granulizer. It's a very basic plugin, but it is the same synthesize technique, so I can use this one as an example. So what is granular synthesis? Granular synthesis is a kind of a sample synthesis again, but one that acts almost like a microscopically on the sample, breaking it down into tiny parts or grains and allowing playback to jump around different grains in the sample. Grain size, volume, position, etc. can be manipulated, resulting in creating new sounds. So, as granular synthesis can be a very powerful way to create new unheard sounds and textures. It is very often employed by sound designers for TV, movies, and video games. So let me see if I can show you an example. I've got a trumpet sample here, and I'm going to load it into the granulizer. So let me put some effects on it, make it sound a little bit better. Very quick reverb. Hitting a wrong note there, sorry for that. So, like I told you, this is a very basic example of granular synthesis, but you get the idea what is going on. Basically, this is like sliced up in very small parts, and you can manipulate the way you play those tiny parts. So the last synthesis form I want to talk about is called physical modeling. Now this one is very interesting. It's a very also a very old form of synthesis, but is recently coming back again. Now, physical modeling is a synthesis method in which the waveform is generated using a mathematical model or a set of equations and algorithms to simulate a physical source of sound. Usually this is a musical instrument, but theoretically it can be anything you want. And so recently plugins like Piano Tech, they created amazing results. I mean, now this is a piano, but these are not samples. All these sounds are computed, so it's digitally generated with mathematical models and equations and algorithms. But it sounds so realistic, it is almost unbelievable. As you can hear, the very low tones and the high tones. It sounds very realistic, and I think there is a lot of things possible with this kind of synthesis techniques. Theoretically, you can create any instrument, and there is also very good examples of realistic trumpets and brass instruments, string instruments, realistic guitars, and all these instruments sounds really, really, really good, like really high quality and realistic. But the interesting thing is you can also create instruments which doesn't exist yet. For example, if you have a mathematical model, an equation of a trumpet, but you change the trumpet in a trumpet of 10 meters long, I don't know how it's going to sound, but you could do crazy stuff like that. So it's a very interesting technique, and also myself, I'm experimenting with this kind of synthesis, and I already had some great results creating kind of new sounds.
Today.